Let alpha equals to pi over 7. Show that sine square 3 times of alpha minus sine square alpha equals to sine of 2 alpha multiplies sine of 3 alpha. So I'm writing the formula we have to use here to find the result. First is, it is the formula from algebra, that is square of a minus square of b is equals to a plus b multiplies a minus b. So when I write sine square 3 times of alpha, this is same as your sine 3 alpha whole square, and this is sine alpha square. So this can be written as sine 3 alpha plus sine, not plus, yes, plus alpha whole into sine 3 alpha minus sine alpha. In the next line, I'm writing all LHS. Here sine 3 alpha plus sine alpha, I'll apply the formula sine A plus sine B, that will be twice sine A plus B by 2, that means A is 3 alpha plus alpha by 2 whole multiplies cos A minus B by 2, so 3 alpha minus alpha by 2 multiplies sine 3 alpha minus sine alpha. We'll apply the formula sine A minus B, that will be cos A plus B by 2, twice cos A plus B by 2, so 3 alpha plus alpha by 2 multiplies sine 3 alpha minus alpha by 2. So in the next step, it will be twice sine 3 alpha plus alpha 4 alpha by 2, that will be twice alpha, and here 2 alpha by 2 is cos alpha multiplies twice, here same the same way it will be cos 2 alpha multiplies sine alpha. So I'll arrange now 2 sine 2 alpha and cos 2 alpha together, twice cos alpha sine alpha together. Then again this can be written in simplified form, applying the formula 2 sine A multiplies cos A is equal to sine twice A. So first one will be sine 2 twice alpha, that will be 4 alpha, and second one will be sine 2 alpha. Now the result is ready. Why? Result is given sine 2 alpha multiplies sine 3 alpha RHS, but sine, I am getting 4 alpha and sine 2 alpha. Is it wrong? No. Why it is cannot be wrong? Because sine 4 alpha is same as your sine pi minus 3 alpha, because alpha is equal to pi by 7 or 7 alpha is equal to pi. So here I'll write when alpha is pi by 7, sine 4 times of alpha can be written as pi minus 3 alpha multiply sine twice alpha. Sine pi minus theta is same as your sine theta. So sine 3 times of alpha into sine 2 times of alpha. The question is, let A, B, C are real numbers given that cos of A plus cos of B plus cos of C is equal to sine of A plus sine of B plus sine of C is equal to 0. That means both terms are equal to 0. We have to prove cos of 2A plus cos of 2B plus cos of 2C is equal to sine of 2A plus sine of 2B plus sine of 2C equals to 0. So let us recall the De Moivre's formula. If Z is a complex number and its modulus is 1, Z is equal to cos alpha plus I times sine alpha. First one is real number and second one is sine alpha is a complex part. Then according to De Moivre's theorem or formula, Z power n is equal to cos n alpha plus I sine n alpha. So we will use this concept here. How? Let, I have taken 3 complex number. X is, let x be cos A plus I sine A. Y is equals to cos B plus I sine B. Z equals to cos C plus I sine C. Then x plus y plus z equals to, adding all these 3, cos A plus cos B plus cos C plus I times sine A plus sine B plus sine C. And it is given that cos A plus cos B plus cos C is 0 and sine A plus sine B plus sine C is 0. So this is equal to 0. Again, if Z is a complex number, that is your cos alpha plus I sine alpha, then its multiplicative inverse 1 over Z is equal to cos alpha minus I sine alpha. So here 1 over x equals to cos A minus I sine A. 1 over y is equals to cos B minus I sine B. But z equals to cos C minus I sine C. Now adding these 3, 1 by x plus 1 by y plus 1 by z equals to cos A plus cos B plus cos C minus I times Sin A plus sin B plus sin C. Again, this is 0 given to be 0. So 1 over x plus 1 over y plus 1 over z is equal to 0. Because cos A plus cos B plus cos C 0, sin A plus sin B plus sin C give 0, it's given. Now simplifying this expression, LCM is xyz. Here yz plus xz plus xy is equals to 0. Or this gives us the result xy plus yz plus zx equals to 0. Now we have to prove that cos 2a plus cos 2b plus cos 2c is equal to 0, as well as sin A, sin twice A plus sin twice B plus sin twice C equals to 0. So next I am taking the help of x square. What will be x square? If x is cos A, what is x? X is cos A plus here I'll write again. So x is equal to this. So according to the De Moivre's formula, x square will be cos 2a plus I sin twice A, y square is equals to cos 2b plus I sin twice b, z square is equals to cos 2c plus I sin 2c. So x square plus y square plus z square equals to x plus y plus z whole square minus 2 times of xy plus yz plus zx. We have proved that x plus y plus z is 0, and here this is again 0. So 2 times of 0 is equal to 0. So what is x square? X square plus y square plus z square is nothing but your cos alpha plus I sin 2 alpha. It's not alpha, sorry, it's A plus cos 2b plus I sin 2b plus cos 2c plus I sin twice c. That means cos 2a plus cos 2b plus cos 2c plus I sin 2a sin 2b sin 2c is equals to 0, because x square plus y square plus z square is equal to 0. So what is 0? 0 means 0 plus I 0. That means real part is also 0 and imaginary part is 0. 0 means 0 plus 0i. So comparing the real parts, this is your cos 2a plus cos 2b plus cos 2c equals to 0, and sin twice a sin twice b plus sin twice c equals to 0 by comparing the real and imaginary parts. So I think it's proved. The question is, compute the sums n combination 1 sin alpha plus n combination 2 sin twice alpha plus up to n combination n sin of n times of alpha. And other sum is, you have to find n combination 1 cos alpha plus n combination 2 cos twice alpha plus so on up to n combination n cos n times of alpha. So here there are two terms. We have to find the sum or two series. So let first series be Sn be sum of first series, then Tn be sum of second series. Now let us take Z is a complex number which is cos alpha plus I sin alpha, and applying De Moivre theorem, formula, know that Z power n equals to cos n times alpha plus I sin n times alpha. If you have problem in this formula, you can watch another video I have already uploaded, that is the derivation of this formula. You can watch and you can be comfortable. Or for the timing, you can also remember or note down this. If Z is equal to cos alpha plus I sin alpha, then Z power n we can write in this way. Okay. Now I am going for a new series 1 plus Tn plus Sn I. This will be 1, and Tn is your n1 cos alpha plus n combination 2, not n1, n combination cos twice alpha up to n combination n cos n times alpha plus I times Sn. Sn is your the bracket n combination 1 sin alpha plus n combination 2 sin twice alpha plus last term is n combination n sine n times alpha. So next I am arranging it. 1 plus n combination 1 cos alpha plus I sin alpha plus n combination 2 cos twice alpha plus I sin twice alpha. So on. Last term is n combination n cos n alpha plus I sin n alpha. This is whole series, that is 1 plus Tn plus Sn plus I. So in the next step, I am writing 1 plus n combination 1. This is nothing but your z power 1. Next is n combination of 2. This is your z power 2, complex number power 2. Up to last will be n combination n, z power n. So this is equal to 1 can be written as n combination 0, z power 0, n combination 1, z power 1, n combination 2, z power 2, up to n combination n, z power n. This is nothing but your 1 plus z to the power n, using combination formula. Okay. So 1 plus Tn plus Sni we got, that is 1 plus z to the power n. Next, let us check what is 1 plus z. 1 plus z is 1 plus cos alpha plus I sin alpha. 1 plus cos alpha is equal to 2 cos square alpha by 2 plus I sin alpha. I can apply the formula 2 sin alpha by 2 multiplies cos alpha by 2, or 1 plus z equal to 2 cos alpha by 2, taking common, I'll get cos alpha by 2 plus I sin alpha by 2. So when z is a complex number, 1 plus z is also a complex number. Again, I can apply the de Moivre formula. N plus z power n will be 2 power n, and cos alpha by 2 power n, so cos n alpha by 2, and here it will be n times, so cos n alpha by 2 plus I sin n alpha by 2. So 1 plus z power n is equals to 2 power n cos alpha by 2. I am separating them, cos n alpha by 2 plus I 2 power n cos n power alpha by 2 multiply sin n alpha by 2. So 1 plus z power n is nothing but your 1 plus tn plus I plus n. So this is equals to power n cos n alpha by 2 cos n alpha by 2 plus I 2 power n cos power n alpha by 2 sin n times of alpha by 2. So next we will compare the real number with real part and imaginary with imaginary. So 1 plus tn is real part, that will be first one, and this imaginary part will be the imaginary part. So this shape will be this one. So Sn is equal to 2 power n cos n alpha by 2 sin n alpha by 2. And Tn is equal to 1 plus Tn is the first one. So Tn will be 1 will be shifted to right side. It will be negative 1 plus 2n cos power n alpha by 2 into cos n alpha by 2. So this is your first series and this is second series. Prove that tan 3x over tan x is equals to tan pi by 3 minus x multiplies tan of pi by 3 plus x. So first I'll apply the formula for tan of 3x. So tan of 3x equals to 3 tan x minus tan cube x whole over 1 minus 3 tan square x. Now writing LHS. LHS equals to tan 3x over tan x equals to 3 tan x minus tan cube x, but tan x was there and here 1 minus 3 tan square x. Next, from the numerator, taking tan x outside, we'll get 3 minus tan square x into tan x 1 minus 3 tan square x tan x cancelled, so it will be 3 minus tan square x over 1 minus 3 tan square x. Now both the numerator and denominator will factorize using the formula a square minus b square. So the numerator will be 3 is root 3 square. So it will be root 3 plus tan x square root 3 minus tan x. In the same way, the denominator will be, this is 3 is root 3 whole square. So it will be 1 square minus root 3 tan x whole square. So 1 plus root 3 tan x into 1 minus root 3 tan x. So in the next step, we'll pair the numerator and denominator in this way. So root 3 plus tan x with the denominator 1 minus root 3 times tan x multiplies root 3 minus tan x 1 plus root 3 tan x. Then it is simple now. Root 3 means tan pi by 3. So it can be written in this way, 10 pi by 3. Or if you remember the formula directly, you can apply 1 minus tan pi by 3 multiplies tan x. Second one will be tan pi by 3 minus tan x and 1 plus tan pi by 3 multiplies tan x. So this is a familiar formula. First one is tan a plus tan b over 1 minus tan a into tan b, that is nothing but your tan pi by 3 plus x tan a plus b, and second one will be the tan a minus tan b over 1 plus tan a into tan b, that will be tan pi by 3 minus x. So this is your right hand side. So you can check once. This is given tan pi by 3 plus x. So RHS hence proved. Thank you for watching. Don't forget to subscribe. If you have not subscribed yet, like, share, and comment down in the comment. Question is, if A, B, C are real numbers such that cos A, cos of B plus cos of C equals to 0, again sine of A plus sine of B plus sine of C is also equal to 0. Prove that cos of A plus B plus C equals to 1/3 of cos of 3 times of A, cos of 3 times of B plus cos of 3 times of C. And also the second part is sine of A plus B plus C is C equals to 1/3 of sine of 3A sine of 3B plus sine of 3C. So the question looks very interesting. So let's start using the De Moivre's theorem and taking your help of complex number. So I'm taking here, let x be a complex number, that is cos A plus I sin A, and y equals to cos B plus I sin B. Z is equal to cos C plus I sin C. Then I am getting a relation x plus y plus z equals to cos A plus cos B plus cos C, taking all real parts, and I sin A sin B plus sin C. Since it is given that cos A plus B plus C is 0, sin A plus B plus C is 0, that means I am getting x plus y plus z is equal to 0. Next, coming to When x plus y plus z equals to 0, taking the help of algebra, that is x cube plus y cube plus z cube minus 3 times of x, y, z equals to x plus y plus z multiplies x square plus y square plus z square minus xy minus yz minus zx. Since x plus y plus z is 0, the whole thing equals to 0. Or x cube plus y cube plus z cube equals to 3 times of x, y, z. Next, coming to how we are applying the De Moivre's theorem. If x is a complex number, that is cos alpha cos a plus I sin a, then from the De Moivre's theorem we know that x to the power n equals to cos n times of a plus I sin of n times of a. So here applying the thing, this formula I can write x cube equals to cos 3 times of a plus I sin 3 times of a. Or y cube cos 3 times of b plus I sin 3 times of b. Similarly, z cube is cos 3 times of c plus I sin 3 times of c. So I am getting x cube plus y cube plus z cube. We had proved that it is x, y, z three times. So applying this complex number concept, I can write cos 3 times of a plus I sin 3 times of a plus cos 3 times of b plus I sin 3 times of b cos 3 times of c plus I sin 3 times of c equals to 3 times of cos 3a plus I sin 3a. Once you understand the concept, you can skip some steps or you can write directly cos 3b. It's not 3, it will be cos a only. C plus I sin c. So what is our left hand side? Left side I am getting cos 3a plus cos 3b plus cos 3c plus I sin 3a plus sin 3b plus sin 3c. And the right side equals to a big expression. Now I'll simplify this. 3 cos a plus I sin a plus b plus I sin b cos c plus I sin c. Now for right hand side, I am writing the first two expressions, that will be cos a plus I sin a multiplies cos B plus I sin B. Let us see what is the result of this expression. If I multiply, this will be cos A cos B plus I sin B cos A plus I sin A cos B plus I square sin A sin B. So on the simplification, I'll get cos A cos B, and the last one I square is -1, so minus sin A sin B, and taking the imaginary part, I'll get I sin B cos A plus sin A cos B. So if you'll recall this is nothing but your A cos A plus B. And next one is I sin A plus B. So see the result, cos A plus I sin A multiplies cos B plus I sin B. I am getting cos A plus B plus I sin A plus B, which is a very interesting result. So applying this concept and expanding further for this cos C plus I sin C, if I take the whole things, 3 times of cos A plus I sin A cos B plus I sin B cos C plus I sin C, you can guess what will be the result. This will be 3 times of cos A plus B plus C plus I sin A plus B plus C. So writing the final result, that was cos 3A plus cos 3B plus cos 3C plus I sin 3A sin 3B plus sin 3C equals to 3 times of cos A plus B plus C plus I sin A plus B plus C. Now I am separating the real part and imaginary part. So we'll get cos 2. So that will be, let us see the again what we have to prove. That will be cos A plus B plus C. Cos A plus B plus C. 3 will be divided here. That will be 1 by 3 cos 3A plus cos 3B plus cos 3C. And comparing the imaginary part, we'll get sin A plus B plus C equals to 1/3 sin 3A plus sin 3B plus sin 3C. I hope you have. Question is, prove that 1 minus cos 23 degree equals to 2 over 1 minus cot 22 degree. It is a trigonometric question. So this is the same as your, we have to prove 1 minus cot 23 degree multiplies 1 minus cot 22 degree equals to 2. So first, let's convert this cot 23 degree in term of sine and cos. Then I'll get LHS equals to 1 minus cos 23 degree upon sine 23 degree whole multiplies 1 minus cos 22 degree upon sine 22 degree. Let's simplify first term, that is LCM will be sine 23 degree, and it will be sine 23 minus cos 23 degree, and second one will be sine 22 degree minus cos 22 degree over sine 22 degree. Now coming to apply some tricks so that it will be a formula. What's that? I'll multiply 1 by root 2 both in the numerator and denominator. So this will be root 2 square root 2 1 over root 2 sine 23 degree minus 1 over root 2 cos 23 degree over sine 23 degree. For second one, again the same principle, square root 2, and here 1 by root 2 sine 22 degree 1 by root 2 cos 22 degree whole upon sine 22 degree. Next is root 2 multiplied, that will be 2. Now this 1 by root 2 I'll write as your cos 45 degree. So cos 45 degree sine 23 degree minus, and this square root 2 I'll write as sine 45 degree cos 23 degree. For sine 23 degree. Similar procedure for the second one, 1 by root 2 your cos 45 degree sine 22 degree. I hope you could understand why I am doing this step, so that I'll convert this expression in term of 45 degree or pi by 4 sine 22 degree. So this is nothing but your sine A cos B minus cos A sine B. You know the formula, that will be sine A minus B. That means 23 degree minus 45 degree. A is 23 here and B is 45. So to the next one. Next one will be sine. Here A is 22 and B is 45. So it will be 22 degree minus 45 degree or sine 22 degree. So here I'll get twice sine 22 degree over sine 23 degree, and the second one sine 23 degree. Sorry, I got a mistake. It will be minus 22 because negative is bigger here. So sine minus 22 degree, and here sine minus 23 degree. And you know that sine minus theta or negative theta is minus sine theta. So there will be two minus will be multiplied outside. That will becomes plus, and it will be sine 20 degree, 22 degree, sine 23 degree, or sine 22 degree and 23 degree. They will be cancelling each other. So 2 minus multiplied, it will becomes your plus. So the answer is 2. So this is your RHS. Hence proved. I have taken a trigonometry question, and this question I will prove with De Moivre's theorem. Prove that cos 2 pi over 7 plus cos 4 pi over 7 plus cos 6 pi over 7 plus half equals to 0. So let's start. So as I told, I'll do it with De Moivre's theorem. That means I'll take the help of complex number. So let z equals to your cos pi over 7 plus I sine 2 pi over 7. Now let us recall some fact about this De Moivre's formula, that is, if z equals to cos theta plus I sine theta, then 1 over z, or reciprocal of complex number, is cos theta minus I sine theta. So z plus 1 by z, certainly it will be twice cos theta, because negative and positive I sine theta will be cancelled. So cos theta equals to half z plus 1 over z. In the same way, let us take another properties, that is, if z equals to cos theta plus I sine theta, z power n is cos n theta, n times of theta, plus I sine n times of theta. So here also cos of n theta equals to half z power n plus 1 over z power n. So putting into this formula, your if I have taken z equals to cos 2 pi by 7 plus I sine 2 pi by 7, then cos 2 pi by 7 equals to z plus 1 by z and half of it. So what about this cos 4 pi by 7? Cos 4 pi by 7 will be half of z square, because 4 pi by 7 is double of 2 pi by 7. So here it will be z power 2, and cos 6 pi by 7 equals to half z cube plus 1 by z cube. It is 3 times of 2 pi over 7, so here z power will be 3. So now we'll replace the original equation. It's given that cos 2 pi by 7 is cos 4 pi by 7 is cos 6 pi by 7 plus half. We'll prove that this equals to 0. So first one will be half z plus 1 over z. Second one will be half z square plus 1 by z square. And third one will be half z cube plus 1 by z cube. And once you understood, no need of writing all the steps what I have written above. You can directly go to this step once you understood the concept. So you won't waste time like me. So here I can take half common. So it will be z square plus 1 over z. Second one will be z4 plus 1 over z square. Third one will be z power 6 plus 1 over z cube, and this is 1. So now I'll multiply z cube and divide z cube to whole expression, or I can take the LCM also. So taking LCM, simplifying, I'll get z cube. So here z square will be multiplied. The second one, z will be multiplied. Third one, 1 will be multiplied. And for 1, it will be z cube. This equals to half z4 plus z square, z5 plus z to the power 6 plus z to the power 3 plus 1 over z cube. Now what? Now is the trick. I'll multiply a z minus 1, both numerator and denominator. Let us see what is happening. So half, I'll multiply a z minus 1. This is z to the power 6 plus z to the power 5 plus z to the power 4 plus z to the power 3 plus z to the power 2 plus z plus 1. Z cube z minus 1. And surprisingly, you will find that the numerator is nothing but your z cube minus z to the power 7 minus 1. You will go on multiplying and cancelling. You will get z power 7 minus 1 by z cube into z minus 1. Next what? Next we got the result. How? Because z equals to cos 2 pi over 7 plus I sine 2 pi over 7. So when I take z power 7, it will be cos 7 multiplies 2 pi by 7 plus I sine 7 multiplies 2 pi by 7 So this will be cos 2 pi and sine 2 pi. Sine 2 pi is 0 and cos 2 pi is 1. So this is equal to z to the power 7 is 1. Z power 7 is 1. That means z to the power 7 minus 1 is 0. So I am getting the numerator as 0. So the 0 over anything will be 0. So the result is 0. So that means cos pi over 7 plus cos 4 pi over 7 plus cos 6 pi over 7 plus half equals to 0 by 2 into z cube into z minus 1 is a big 0. Hence proved. So please don't think that it is a lengthy method. I have explained on all the background. That's why it took time. When you will solve the question, once you understand the De Morgan's theorem, you will be very fast to find the answer. Thank you. Triangle ABC show that sine half A multiply sine half B multiply sine half C is less than equal to 1 over 8. In this question, so many concepts are involved. So if you are really interested to learn, please watch the video from beginning to end. I'm sure you will learn so many concepts and you will learn how to apply in different questions. So here, first concept I will take, that is your law of sine. What is law of sines? If in any triangle A, B, C, and BC is taken as small a, AC is taken as small b, and C is taken as AB is taken as small a, the ratio of side A to sine of angle A is equals to ratio of B side B to angle sine of B is same as your ratio of side C to angle of sine C. So this is called law of sine. So we can take this is a ratio K. Taking this, now I'll prove next is sine A by 2 or sine half A is less than equal to small a by B plus C, and sine B half B is less than B by A plus C, and sine half C is less than C by A plus B. If we will prove one, we can, by symmetry, you can write other things. So I am going for the first one. So to prove sine A half A is less than equal to this, I am taking the right hand side of this. I am proving this one. I am taking the right hand side, that is A over B plus C. For small a, I am taking this ratio now, because I have taken each ratio as a constant k, that instead of side A, I can write k times of sine angle A, and for B, k times of sine angle B, and k times of sine C, because each is equal to k. So A is equal to sine k multiply sine A, B is equal to k multiply sine B, C is equal to k multiply sine C. Now taking k outside from the numerator and denominator, I will taking sine A over sine B plus sine C. So always focus what I have to prove. I have to prove that this is greater than sine A by 2. So I have to convert this angle A into A by 2 form. So I'll apply the double formula, double angle formula. So instead of sine A, I'll write 2 sine half A cos half A. And for the denominator, I'll apply sum of product. So this will be 2 sine B plus C by 2 multiplies cos B minus C by 2. So again on simplification, I can cancel 2. So this will be 2 sine A over 2 cos A over 2 or half A. And for the denominator, I am changing this sine B plus C by 2. We know that in any triangle, A plus B plus C is your 180 degree. So A by 2 plus B by 2 plus C by 2 is equal to 90 degree. So sine B plus C by 2 equals to sine 90 minus A by 2 half A. That will be cos A by 2 cos half A. So in the denominator, I'll write 2 cos A over 2 and no change in cos B minus C by 2. 2 cancel, cos A cancel. Ultimately, I'm getting this ratio sine half A over cos B minus C by 2. So I have to prove that this is greater than sine A by 2 because I have taken the right hand side sine A by 2. I'll prove that this equals to this ratio equals to greater than equal to sine A by 2. That means the ratio is greater than your this denominator should be less than 1. What is the logic? So for in any triangle B minus C, the difference of any two angles is always your either equal to 0 if they are equal, or it is less than 180 degree because sum of angles of a triangle is 180 degree, or 0 less than equal to B minus C by 2 is 90 degree. I repeat, I am going to prove that the denominator is less than 1 so that the whole will be your greater than sine A by 2. Now taking the cos function for these inequalities, again you have to take care because cos function or cos x, cos theta decreases from 0 to 90. Cos theta for any angle theta decreases from, or it is a decreasing function from 0 to 90. So inequality will be changed when I take the cos function. So cos 0 degree is greater than equal to cos B minus C, here greater than again cos 90. This implies that cos 0 is 1, 1 is greater than cos B minus C by 2. So cos B minus C is less than equal to 1. So ultimately sine A by 2 over cos B minus C by 2, it is always greater than equal to sine A by 2. So what was this? This was A over b plus c is greater than equal to sine a by 2. We have proved. This is all. This is also a part of the question. It can be a whole question also to prove this. So sine a by 2 half a is less than equal to ratio of a to b plus c. So by symmetry we can write this one b by a plus c sine c by 2 is less than equal to c by a plus b. So now multiplying these three relation, I'll get sine a by 2, sine b by 2, sine c by 2 is less than equal to a over b plus c multiplies b over a plus c multiplies c over a plus b. We have to prove that this is less than equal to 1 over 8. Now coming to the final part of this solution. Now a, if we'll take this terms or this product, it is nothing but your a b c over b plus c, a plus c and a plus b. So for this relation we will be applying the concept arithmetic mean of two numbers is always greater than equal to geometric mean. That means your a plus b by 2 is greater than square root of ab, that is geometric mean, or a plus b is greater than equal to twice root ab. The same way b plus c is greater than equal to twice bc, and c plus a is greater than equal to twice ac. This product of, or this denominator, b plus c, a plus c and a plus b is your equals to or greater than equal to 2ab, 2bc, 2ac, greater than equal to 8 a square, b square, c square. So this is greater than equal to 8 abc. So abc, when the denominator is greater than 8 abc, and abc over b plus c, a plus c, a plus b, the denominator is greater than abc, and certainly it will be taking the equality sign. I can get this is equal to abc by abc, 8 abc. So this is your 1 by 8, taking the equality sign. So our purpose is solved now. Sine half a, sine half b, sine half c is less than equal to by 8. So hence proved. Today I have taken a very small concept in trigonometry which is very useful to solve advanced problem in trigonometry. So we must learn this. Question is, prove that sine of 18 degree equals to square root 5 minus 1 whole over 4. So let's take theta is 18 degree. That means 5 times of theta equal to 5 multiplies 18, that is 90 degree. Again, if I can change 5 theta as 2 theta plus 3 times of theta, that is 5 theta is equal to 90 degree. Or arranging 2 theta to side, one side, I can get 90 degree minus 3 times of theta. Now I'll take sine function both the sides. So it will be sine twice theta equals to sine 90 minus 3 times of theta, and we know that 90 minus a is cos a, so it will be cos 3 theta. Now applying the formula for sine twice theta, it is your 2 sine theta cos theta, and cos 3 theta equals to 4 cos cube theta minus 3 cos theta. So since cos 18 is not equal to 0, I can cancel cos theta from both the sides, so that I'll get a new equation twice sin theta equals to 4 cos square theta minus 3. Because this I can take cos theta to cancel, that will be 4 cos square theta minus 3. Now shifting all the terms to left side, I'll get 2 sin theta minus 4 cos square theta plus 3 equals to 0. In the next step, we'll change this cos square theta as 1 minus sin square theta. So I'll get 2 sin theta minus 4 into 1 minus sin square theta plus 3 equals to 0. This gives us 2 sin theta minus 4 plus 4 sin square theta plus 3 equals to 0. Arranging according to the exponent or power, I'll get 4 sin square theta plus 2 sin theta minus 1 equals to 0. So this is a quadratic equation in terms of sin theta. So let's put the formula for quadratic formula to find the value of sin theta. Sin theta equals to minus b, b is here 2, negative b plus minus b square, 2 square is 4, minus 4ac, a is 4 here, and this will be minus 1, so it will be 4 times 16, whole upon 2 into 4, that will be 8. So this gives us minus 2 plus minus square root 20 can be written as 2 root 5, 8. Now taking 2 common, I'll get negative 1 plus minus square root 5 over 8, cancelling, it will be 4. So this is equal to minus 1 plus minus square root 5 over 4. So I am getting sin theta as two values. One is sin theta equal to negative 1 negative root 5 over 4 and negative 1 plus roots under root 5 over 4. So now the question is, which one will be correct, or both will be the correct. Now see, sine 18 degree, theta is 18 degree, so sine 18 is an acute angle. It is between 0 to 90 degrees, so it is always positive. So if I take this negative one, it will be negative, so it is not possible, because sine 18 degree is your positive. So sine 18 equals to square root 5 minus 1 over 4. Question is to prove cos 9 degree equals to 1/4 of whole square root 3 plus under root 5 plus square root of whole 5 minus under root of 5. This is a very interesting question. Now immediately it comes to our mind that cos 9 degree can be written as cos 45 degree minus 36. And by the formula you can expand, you can get the result. But this particular values you may not get by proceeding in that way, or it may be lengthy. So we would like to solve it with a simple way. That is, here I am taking the help of your sine 18 degree. How is it? I will write sine 9 degree plus cos 9 degree whole square equal to sine square 9 degree plus cos square 9 degree plus twice sine 9 degree cos 9 degree, or sine 9 degree plus cos 9 degree whole square equals to, this 2 makes you 1, sin square theta plus cos square theta, and again this will give us sine 18 degree. 2 sin theta cos theta is sine twice theta, so plus sine 18 degree. Sine 18 degree equals to under root 5 minus 1 over 4. I have a separate video today only I have uploaded to prove this, so that we can use this in this particular question. The link is given, you can go for it. So now coming to the above line, I'll write sine 9 degree plus cos 9 degree whole square equal to 1 plus square root 5 minus 1 over 4. Let us simplify this. It will be 4 plus under root 5 minus 1 over 4, or sine 9 degree plus cos 9 degree whole square equals to 3 plus under root 5 by 4. Now from this I am taking the square root from both the sides. So sine 9 degree plus cos 9 degree equals to under root 3 plus under root 5 over 4. So this will be plus minus square root 3 plus square root 5 over 2. So now cos 9 degree and sine 9 degree both are positive, because 9 is acute angle in the first quadrant, so it cannot be your negative value, so this will be your positive. Negative is not negative, it will be positive. So I can write this is equal to root 3 plus root 5 over 2. That means under root of 3 plus whole 3 plus under root 5 by 2. It is, since it is greater than 0. Y sine 9 degree plus cos 9 degree is greater than 0. Next, I'll go for symmetry. What is it? Sine 9 degree minus cos 9 degree whole square. This gives me sine square 9 degree plus cos square 9 degree minus 2 sine 9 degree cos 9 degree, or directly I can write now this will be sine 18 degree, or sine 9 degree minus cos 9 degree whole square equals to 1 minus sine 18. Sine 18 we have already found out, right? 105 minus 1 by 4. So this equal to, on simplification, 4 minus under root 5 plus 1 over 4, or sine 9 degree minus cos 9 degree whole square equals to 5 minus under root 5 over 4, or taking square root both the sides, I'll get sine 9 degree minus cos 9 degree equals to plus minus under root 5 minus under root 5 over 4. This will be plus minus under root 5 minus under root 5 over 2. Now which one will be correct? Will it be plus or it will be minus? It will be definitely negative. Why? Because you know that in first quadrant from 0 to 45 degree, 0 degree to 45 degree, cos theta is greater than sin theta, and at 45 they becomes 1. So sin 9 degree minus cos 9 degree is less than 0. So which value will be correct? The negative will be correct. So cos sin 9 degree minus cos 9 degree equals to negative 5 minus under root 5 whole square root by 2. So let us go for the first equation. Cos 9 plus cos this one. This one was this much. Let me write the equation now. Sin 9 degree plus cos 9 degree was your 1 by 2 square root 3 plus square root 5. And sin 9 degree, I am getting equation 2 minus cos 9 degree equals to negative half the root 5 minus under root 5. Now subtracting first equation from the second one, subtracting equation 2 from 1, sin 9 will be cancelled. It will be a 2 cos 9 degree equal to, you are adding, subtracting this, so it will be half under 3 plus under root 5 is half 5 minus under root 5. So what about the cos 9 degree? 2 will be divided. So cos 9 degree equals to 1 by 4 square root of whole 3 plus under root 5 plus square root of whole 5 minus under root 5. So I hope you enjoyed it. Thank you for watching. So question is, prove that cos cube of pi by 9 minus cos cube 4 pi by 9 plus cos cube 7 pi by 9 equals to 3 over 8. Okay. So first I'll discuss two formulas here. One is your cos 3 theta. We know that cos 3 theta equals to 4 cos cube theta minus 3 cos theta. Since it is cos cube, so I can convert this 4 cos cube theta equals to cos 3 theta plus 3 cos theta, or cos cube theta equal to 1 by 4 cos 3 theta plus 3 cos theta. So we can individually put for cos cube pi by 9, cos cube 4 pi by 9 and cos cube 7 pi by 9. But for cos 7 pi by 9, I am making an acute angle. Cos 7 pi over 9 can be written as cos pi minus 2 pi by 9. It will simplify 9 pi minus 7 pi by 2. So cos pi minus theta, we know that it is negative of cos theta. So it will be cos 2 pi by 9. Now cos cube 7 pi by 9 can be written as minus cos 2 pi by 9 whole power 3. So this is negative cos cube 2 pi by 3, because negative power 3 is minus 1 power 3 equals to negative, so minus cos cube 2 pi by 3. Sorry, 2 pi by 9. Very sorry, it will be 9. So coming back to the question. So the question was cos cube pi by 9 minus cos cube 4 pi by 9. And this third one I'll write minus negative cos cube 2 pi by 9. So we'll put the formula now for this one. So it will be 1 by 4 cos 3 theta minus plus 3 cos theta. So first one will be 1 by 4. Here theta is your pi by 9. Cos 3 theta will be cos 3 pi by 9 plus 3 cos pi by 9. I hope it's okay. Next, second one. Second one will be minus 1 by 4. Here theta is 4 pi by 9, so it will be multiple of 3. So it will be cos 12 pi by 9 plus 3 cos 4 pi by 9. The last one will be 1 by 4. It will be theta is 2 pi by 9, so it will be 3 times. It will be cos 6 pi by 9 plus 3 cos 2 pi by 9. Now we will simplify all this to make 3 by 8. So it will be 1 by 4 cos 3 pi by 9. Next is minus 1 by 4 cos 12 pi by 9 minus 1 by 4 cos 6 pi by 9. And second one is, this will be plus 1 by 4, or I can take common 3 by 4 because this term 3, 3, 3 will be 3 by 4. I am taking common. So within bracket it will be cos pi by 9. Here it will be negative because negative sign is there. Minus cos 4 pi by 9. And here it will be also negative because negative sign is there. So minus cos 2 pi by 9. Okay. Now from the first 3 terms, I'll take 1 by 4 common and I'll simplify a little bit. Cos 3 pi by 9 can be written as cos pi by 3. And here cos 12 pi by 9 equal to 4 pi by 3, cos 4 pi by 3. And here also negative, it will be 2 pi by 3. Plus 3 by 4. I'm not simplifying in this step. Have patience, I'll simplify in the next step. 4 pi by 9 minus, I'm writing as it is, cos 2 pi by 9. Then we'll go for simplification. So in the next step, I'm getting 1 by 4 cos 3 pi by 9 is same as 1 by pi by 3. 1 by 4 I'll take common from first 3 terms. Cos pi by 3, this is pi by 3. Here it will be minus cos 4 pi by 3 and here cos 2 pi by 3. Plus in the second term 3 pi by 4, it will be cos pi by 9. I'll take minus common so that it will be cos 4 pi by 9 plus cos 2 pi by 9. So now how to simplify? Here I'll put this formula. What? One is cos 4 pi by 3 is nothing but your cos pi plus pi by 3. Cos pi plus pi by 3, we are in third quadrant, that is negative cos pi by 3. And cos 2 pi by 3 can be written as cos pi minus pi by 3. That is in second quadrant, again it will be minus cos pi by 3. So the first term will be, two formula will apply. And for the second one, I'll apply cos 4 pi over 9 plus cos 2 pi over 9. That will be cos A plus cos B equal to 2 cos A plus B by 2. So 4 pi 9 plus 2 pi by 9 whole divided by 2 cos a plus b by 2 into cos a minus b by 2, 4 pi by 9 minus 2 pi by 9 whole divided by 2. So now this 1 by 4, cos, I'm getting back to the expression I have to prove cos pi by 3. Instead of this, I'll get negative minus cos pi by 3. So minus cos pi by 3. And for the third term, again for this, I'm getting your minus cos pi by 3. So minus cos pi by 3. This is the first term. So first term I'm getting 1 by 4 cos pi by 3 plus cos pi by 3 plus cos pi by 3. 3 times. So this is equal to 1 by 4 multiplies 3 cos pi by 3. Cos pi by 3 we know it is 60 degree. So 1 by 4 into 3 into 1 by 2, that will be 3 by 8. Now coming to the second term. This is the first term. Now second term is 3 by 4 whole into cos pi by 9 minus within bracket cos 4 pi by 9 plus cos 2 pi by 9. We discussed the formula I will apply here. That is here. This is the result. So this will be 3 by 4 into cos pi by 9 minus 2 cos 4 plus 2, 6 by 18. 6 pi by 18. I had simplified here only. So this will be 6 pi by 18 and this will be 2 pi by 18. Cos 2 pi by 18. So this is 6 by 3, pi by 3 and this will be pi by 9. This is equal to 3 by 4 cos pi by 9 minus 2 cos pi by 3 into cos pi by 9. So cos pi by 9, I'll take common from both the term. Cos pi by 9 no need of taking common. Pi by 9, this 2 pi by 3 will be half. Sorry, I am making it lengthy. 3 by 4 into cos pi by 9 minus 2 into pi by 3 is 1 by 2 and cos pi by 9. So cos pi by 9 minus cos pi by 9, it will be 0. So second term is 0. The whole expression cos q pi by 9 minus cos q 4 pi by 9 plus cos q 7 pi by 9 was, first term was 3 by 8. Now it is 0. So 3 by 8 plus 0. So the answer 3 by 8, sorry. 3 by 8 plus 0. So the answer is 3 by 8. Hence proved. So question is, let fk of x equal to 1 over k of whole sine power kx plus cos power kx for k equals to 1, 2, 3, so on. Prove that f4 of x minus f6 of x is equal to 1 by 12 for all real values of x. So let's start. Now let us see what is the meaning of this. F of k means if we will take k is equal to 1, then fx equals to sin x plus cos x. If k is equal to 2, then your f2x equals to 1 by 2 into sin square x plus cos square x, so on. So what is the meaning of f4x? That is same as your 1 by 4 sin power 4x plus cos power 4x. And what is f6 of x? That will be 1 by 6 into sin power 6x plus cos power 6x. So what is the question now in the simple language? We have to prove 1 by 4 sin 4x plus cos 4x power 4, not 4, minus 1 over 6 into sin power 6x plus cos power 6x equals to 1 by 12. Or I need to prove, if I'll multiply 12 throughout, I have to prove that 3, when I'll multiply 12 here, it will be 4, 3 times 12. So 3 times of sin 4x, sin power 4x plus cos power 4x minus, when I'll multiply 12 here, it will be 12 by 6. That will be 2 sin power 6x plus cos power 6x equal to 1 by 12 into 12, that will be 1. So to prove this one, this is the question now, modified question. So coming to left hand side, LHS. So LHS is equal to 3 sin power 4x plus cos power 4x minus 2 sin power 6x plus cos power 6x. So here we'll apply just algebra. A square minus b square, you know the formula. A plus b whole square minus 2ab. So it will be sin square x plus cos square x whole square minus 2i is sin square x into cos square x. And for second one, this is aq plus bq. If I'll take as a, I'm taking as sin square x and b is cos square x, then this will be aq plus bq. So this is nothing but a plus b into a square plus b square minus ab. So this will be minus. Here I am just continuing in the second line, minus 2 times of sin square x plus cos square x. This is your a plus b into a square sin power 4x plus b square cos power 4x minus sin square x cos square x. So in the next step, we know that sin square x plus cos square x is 1. So this will be 1 square 1 and this will be also 1. So next line I'll write 3. This will be 1 minus 2 sine square cos square x. This is the first term, and the second term will be minus 2 multiplies, this is your 1, into, now I will break this one as your sine square x plus cos square x whole square minus twice sine square x into cos square x. Previously there was another sine square x cos square x. So this is 3, and just I am now multiplying 3 into 3, 3 minus 6 sine square cos square x, sine square x cos square x. So this is about first term. Now I will go for the second term. It will be minus 2. This is 1 again. So it will be 1 minus, this is your makes 3, 3 sine square x cos square x. So simplify now. 3 minus 6 sine square x cos square x minus 2 plus 6 sine square x cos square x equal multiply this one. This 2 will be cancelled. The answer is 1. So if you prove it, that is your f of 4 x minus f of 6 x equals to 1 by 12. Question is, solve 32x power 5 minus 40x power 3 plus 10 times of x equals to 1. It's not quadratic, it is not cubic, it is a equation of power 5. So it is not that easy to solve unless we take some trigonometric function. So to take this function, first I should recall, or I should think critically which function I can apply and which I can convert. So it comes to my mind that I can take the help of your cos 5 alpha. Cos 5 alpha equals to your 16 cos to the power 5 alpha minus 20 cos cube alpha plus 5 cos alpha. So if I can take x as cos alpha, I can put into this format of the equation. Now how to prove this cos 5 alpha is equal to this? It is very easy. You can write cos 5 alpha equals to cos 3 alpha plus 2 alpha. Putting the formula for cos a plus b, it will be cos 3a alpha cos 2 alpha minus sin 3 alpha sin 2 alpha. So next I'll put formula for cos 3 alpha, that is equal to, or cos 5 alpha, I'm proving this, equal to cos 3 alpha is equal to 4 cos cube alpha minus 3 cos alpha, and cos 2 alpha is equal to your 2 cos square alpha minus 1. And the second one, I'll put the formula sin a sin b, that will be half cos a minus b, so 3 alpha minus alpha, and minus cos a plus b, 3 alpha, it is 2 alpha, 3 alpha plus 2i's alpha. Or we are getting cos 5 alpha equals to, your multiplying, it will be 8 cos power 5 alpha minus 4 cos cube alpha minus 6 cos cube alpha plus 3 cos alpha. And here within bracket I am getting half. This is your cos alpha minus half cos 5 alpha. And this will be positive. Now taking to left side, I'll get half cos 5 alpha equals to your 8 cos power 5 alpha minus 4 minus 6, it becomes minus 10 cos cube alpha, and 3 cos alpha minus half cos alpha gives you 5 by 2 cos alpha. Now multiplying throughout by 2, I'll get cos 5 alpha equals to your 16 cos power 5 alpha minus 20 cos cube alpha plus 5 cos alpha. So you learned a new formulas which you can stock in your memory and you can reuse when we according to your convenience or requirement. So here coming to the original equation, so 32x to the power 5 minus 40x cube plus 10x equals to 1, or taking 2 common, not half, I'll get 16 x to the power 5 minus 20 x cube plus 5x is equal to 1. So now I'll take let x equal to cos alpha, then 16 x to the power 5 minus 20 x cube plus 5x equals to cos 5 alpha. So what we are getting now? We are getting 2 cos 5 alpha equals to 1, or cos 5 alpha equals to half. Then directly we came from trigonometry to algebra to trigonometric equation. Half means your cos pi by 3, cos 60 degree. We know that cos alpha is equal to cos theta. That time alpha equals to 2n pi plus minus theta. So here in place of alpha it is 5 alpha. So this is your 5 alpha equal to 2n pi, when of course n is an integer. We have to mention 2n pi plus minus pi by 3 when n is an integer. Then what about alpha? So alpha equal to 2n pi by 5 plus pi by 15 plus minus pi by 15. So it is an equation of degree 5, that means it has 5, at most 5 real solutions. It has at most 5 real solutions. Hello friends, I am Pratima. I welcome you all to my channel. Today I have taken a question to solve quintic equation. Question is, solve 32x power 5 minus 40x power 3 plus 10 times of x equals to 1. It's not quadratic, it is not cubic, it is a equation of power 5. So it is not that easy to solve unless we take some trigonometric function. So to take this function, first I should recall, or I should think critically which function I can apply and which I can convert. So it comes to my mind that I can take the help of your cos 5 alpha. Cos 5 alpha equals to your 16 cos to the power 5 alpha minus 20 cos cube alpha plus 5 cos alpha. So if I can take x as cos alpha, I can put into this format of the equation. Now how to prove this cos 5 alpha is equal to this? It is very easy. You can write cos 5 alpha equals to cos 3 alpha plus 2 alpha. Putting the formula for cos A plus B, it will be cos 3A alpha cos 2 alpha minus sin 3 alpha sin 2 alpha. So next I'll put formula for cos 3 alpha, that is equal to, or cos 5 alpha, I'm proving this, equal to cos 3 alpha is equal to 4 cos cube alpha minus 3 cos alpha, and cos 2 alpha is equal to your 2 cos square alpha minus 1. And the second one, I'll put the formula sin A sin B, that will be half cos A minus B, so 3 alpha minus alpha, and minus cos A plus B, 3 alpha, it is 2 alpha, 3 alpha plus 2 is alpha. Or we are getting cos 5 alpha equals to, your multiplying, it will be 8 cos power 5 alpha minus 4 cos cube alpha minus 6 cos cube alpha plus 3 cos alpha. And here within bracket I'm getting half. This is your cos alpha minus half cos 5 alpha. And this will be positive. Now taking to left side, I'll get half cos 5 alpha equals to your 8 cos power 5 alpha minus 4 minus 6, it becomes minus 10 cos cube alpha, and 3 cos alpha minus half cos alpha gives you 5 by 2 cos alpha. Now multiplying throughout by 2, I'll get cos 5 alpha equals to your 16 cos power 5 alpha minus 20 cos cube alpha plus 5 cos alpha. So you learned a new formulas which you can stock in your memory and you can reuse when we, according to your convenience or requirement. So here coming to the original equation, so 32x to the power 5 minus 40x cube plus 10x equals to 1, or taking 2 common, not half, I'll get 16x to the power 5 minus 20x cube plus 5x is equal to 1. So now I'll take let x equal to cos alpha, then 16x to the power 5 minus 20x cube plus 5x equals to cos 5 alpha. So what we are getting now? We are getting 2 cos 5 alpha equals to 1, or cos 5 alpha equals to half. Then directly we came from trigonometry to algebra to trigonometric equation. Half means your cos pi by 3, cos 60 degree. We know that cos alpha is equal to cos theta. That time alpha equals to 2n pi plus minus theta. So here in place of alpha it is 5 alpha. So this is your 5 alpha equal to 2n pi, when of course n is an integer, we have to mention 2n pi plus minus pi by 3 when n is an integer. Then what about alpha? So alpha equal to 2n pi by 5 plus pi by 15 plus minus pi by 15. So it is an equation of degree 5, that means it has 5, at most 5 real solutions. it has at most 5 real solutions. So to define the 5 alpha and as well as alpha, so n should be here 0, n should be 1, and n should be 2. So let us go one by one. When n is equal to 0, alpha is equal to your 0 plus pi by 15, that is equal to your pi by 15. Now n is equal to 1, that time alpha is equal to your 2 pi by 5 plus pi by 15 and 2 pi by 5 minus pi by 15. So this will be 7 pi by 15, and this is equal to your pi by 3, pi by 15, 5 pi by 15, that will be pi by 3. And when n is equal to 2, alpha equals to 4 pi by 5 plus pi by 15, and alpha equals to 4 pi by 5 minus pi by 15. This is equal to 13 pi by 15. 13 pi by 15 can be written as minus pi by 15, minus 2 pi by 15. And here it is equal to 11 pi by 15, or this is minus 4 pi by 15. So what are the solutions? Solutions are cos pi by 15, cos 7 pi by 15, cos pi by 3, cos minus 2 pi by 15. Of course, that will be same as your pi by 15, and your cos minus 4 pi by 15. This is same as your 4 pi by 15. So there are 5 solutions. Thank you for watching. Thank you for subscribing my channel. Keep on watching, keep on learning. There is no end of learning. Thank you. So to define the 5 alpha and as well as alpha, so n should be here 0, n should be 1, and n should be 2. So let us go one by one. When n is equal to 0, alpha is equal to your 0 plus pi by 15, that is equal to your pi by 15. Now n is equal to 1, that time alpha is equal to your 2 pi by 5 plus pi by 15 and 2 pi by 5 minus pi by 15. So this will be 7 pi by 15, and this is equal to your pi by 3, pi by 15, 5 pi by 15, that will be pi by 3. When n equals to 2, alpha will be 4 pi by 5 plus pi by 15 equals to 13 pi by 15, and again alpha will be 4 pi by 5 minus pi by 15 equals to 11 by 15, 11 pi by 15. So the solutions are cos pi by 15, cos 7 pi by 15, cos 5 pi by 15, that is pi by 3, cos 13 pi by 15, and cos 11 pi by 15. Or we can write x is equal to cos pi by 15, cos 7 pi by 15, 1 by 2 cos pi by 3 is 1 by 2, negative cos 2 pi by 15, and negative cos 4 pi by 15. That is, prove that cos 5 times of theta equals to 16 cos power 5 theta minus 20 cos power 3 theta plus cos theta. So starting from left side, cos 5 theta equals to 3 theta plus 2 theta, or cos 5 theta equals to, I am expanding the right hand side with the formula, that is, we know that cos A plus B equals to cos A cos B minus sin A sin B. So it will be cos 3 theta cos 2 theta minus sin 3 theta sin 2 theta. So next is cos 3 theta. Cos 3 theta equals to 4 cos cube theta minus 3 cos theta, and your cos 2 theta equals to 2 cos square theta minus 1. So replacing this, I'll get cos 5 times of theta equals to 4 cos cube theta minus 3 cos theta full into 2 cos square theta minus 1. Next is your sin 3 theta sin 2 theta. For this, sin A sin B, will again put the formula, that is half of cos A minus B minus cos A plus B. So if you can remember or recall these four formulas, this question is not difficult. So here it will be half cos A minus B, so 3 theta minus 2 theta minus cos 3 theta plus 2 theta. So next, cos 5 theta equals to, just go on multiplying, it will be 8 cos 5 power 5 theta, then your minus 4 cos cube theta minus 6 cos cube theta plus 3 cos theta, and here it will be minus half cos theta plus half cos 5 theta. So again I am getting a cos 5 theta terms on the right hand side. So we'll shift to left hand side. So it will be cos 5 times of theta minus half cos 5 theta equals to 8 cos power 5 theta, and these two will combine to give you minus 10 cos cube theta. Then this cos theta will simplify. It will be 5 over 2 cos theta. So you will subtract, it will be half cos 5 theta equals to 8 cos 5 theta minus 10 cos cube theta plus 5 by 2 cos theta. So we'll multiply throughout with 2. Then left hand side will be cos 5 theta equals to 16 cos power 5 theta minus 20 cos cube theta, and here 2 will be cancelled, it will be 5 cos theta. So hence we proved the formula. Why I discuss this? Because in the next problem I am going to solve, we will need this formula. Thank you for watching. Thank you for subscribing my channel. So don't forget to subscribe. If you have not subscribed, like and share and comment. So today's question is, in a triangle ABC, prove that sine A, sine B, sine C less than equal to 3 square root 3 over 8. So we'll apply Jensen's inequality to prove it easily. For this, let us recall a fact that is your, in the last video also there is another video where I have proved that sine of A plus sine of B plus sine of C is less than equal to sine A plus B plus C over 3. This equal to, or this is sine A plus sine B plus sine C is less than equal to sine 180 by 3 sine 60 degree. So root 3 by 2 whole multiply 3. So we'll use this result, and this result I got directly using shortcut as sine function is your concave in 0 to pi by 2, and here this A, B, C are in between this. So it will be 3 root 3 by 2. So this is the previous proved uh, result. Now sine A, sine B, sine C. Suppose sine A, sine B, sine C are 3 real, then we know that arithmetic mean is greater than or equal to geometric mean, or geometric mean is less than or equal to arithmetic mean. So if we take the geometric mean of sine A, sine B, sine C, it will be cube root of sine A, sine B, sine C. That will be less than or equal to their arithmetic mean. It is sine A plus sine B plus sine C over 3. And this we have proved to be how much? Root 3 by 2. So comparing first and third, you will get cube root of sine of A, sine of B, sine of C is less than or equal to root 3 by 2. Now take power 3 both the sides, so it gets sine of A, sine of B, sine of C is less than equal to root 3 by 2 whole cube. That will be your 3 root 3 over 8 because they are equal to each other. So hence the result is proved. Today's question is from trigonometry inequality. In a triangle ABC, prove that product of cos A, cos B, cos C is less than equal to 1 over 8. So I'm little bit changing the question. I'll prove that to prove 2 cos A, cos B, cos C is less than equal to 1 by 4. This is the same meaning. So now LHS equals to 2 cos A, cos B, cos C. Here I'll apply formula for 2 cos A, cos B. We know that this is cos A plus B plus cos A minus B. Will multiply cos C. So now A plus B plus C equals to 180 degrees since ABC is a triangle. So A plus B equals to 180 minus C. So I can take the cos function both the side so that it will be cos A plus B equals to cos 180 minus C is equal to nothing but your minus cos C. So I'll replace here. So this is equal to cos A minus B I am writing first because this will become negative. So minus cos C whole into cos C. Or this is same as your cos A minus B into cos C minus cos square C. Now taking the inequality. What's it? We know that for any acute angle AB, cos A minus B is equal to greater than equal less than equal to 1. If it is A is equal to B, then it equal to 1, or it is less than equal to. Let me write clearly. So this is less than equal to 1. So the left hand side twice cos A cos B cos C, here less than equal to cos A minus less than 1, so it will be cos C minus cos square C. Now I'll make it to a complete square. What I'm doing, just please note, 1 by 4 I am adding and I am subtracting a 1 by 4. I'll make the all the three terms in this way. This is cos square C plus 1 by 4 minus cos C. So this is your nothing but your cos C minus half square. And you know that any square cos C minus half square is always positive rather than equal to 0. So if this is 0, 1 minus 4, it is will be less than 1 by 4. So this proves that cos A, cos B, cos C is less than equal to 1 over 8. Proved. think the question is, in a triangle ABC, prove that tan of half A multiplies half B, tan of half B multiplies tan of half C less than equal to square root 3 over 9. So let's proceed. For this question, I'm supplementing this with another question, that is your tan of A by 2, tan of B by 2 plus product of tan of C by B by 2 multiplies tan of C by 2 plus product of tan A by 2 and tan C by 2 is equal to 1. I am proving this. So how to prove this? It is a triangle, so A plus B plus C is equal to 180 degree. That means if I take A by 2 plus B by 2 plus C by 2 equals to your pi by 2, that will be 90 degree. That means A plus B by 2 equals to 90 degree minus C by 2. Or taking tan function, I'll get tan A plus B by 2 or A by 2 plus B by 2 equals to tan 90 minus C by 2, and we know that this is your cot C by 2. So I am expanding this left hand side. LHS is tan A by 2 plus tan B by 2 over 1 minus tan A by 2 B by 2. Now this is equal to cot C by 2, so this can be written as 1 by tan C by 2. So now I'll cross multiply. So I'll get tan A by 2, tan C by 2 plus tan B by 2, C by 2 equals to 1 minus tan A by 2 into tan of B by 2. Now shifting the last one to left hand side, I am getting the desired answer. 10 A by 2, C by 2 plus 10 half B, half C, 10 half A, 10 half B equals to 1. So if you know already, or you are able to, no need of this proving this, then we can write the result. Now we have to prove, I'm rewrite the question to prove tan A by 2, tan B by 2, tan C by 2 is less than equal to square root 3 by 9. So I am taking your arithmetic and geometric inequality. So there are three numbers here. One is tan A by 2, tan B by 2, tan C by 2. No, I am taking this whole numbers. These are the numbers. So AM of tan A by 2, tan C by 2, that means whole two together, not only the separately. Tan C by 2 plus tan b by 2 into a by 2 whole by 3. So terms I have taken 2 together. That means this is one term, this is one, this is another one. So arithmetic mean is divided by 3. And what about the geometric mean? Geometric mean equals to cube root of tan a by 2 tan c by 2 one term, multiplication tan b by 2 tan c by 2 second term, third term is tan a by 2 tan b by 2. Now we know that am gm is less than am. So cube root of, now see you are getting tan a 2 times, so tan square a by 2 tan square b by 2 tan square c by 2 is less than equal to, this arithmetic mean is I've already mentioned, and this numerator value is 1, so 1 by 3, or tan square a by 2 tan square b by 2 square c by 2 3 power 1 by 3. This is same as your tan a by 2 tan b by 2 tan c by 2 whole power your 2 by 3. So this is less than equal to 1 by 3. Tan a by 2 tan b by 2 tan c by 2 is less than equal to 1 by 3 power 2 by 3. It will be not 2 by 3, by mistake I have written, it will be 3 by 2, then only it will be simplified. So this will be your 3 1 open 27 square root. So this is equal to 1 by 3 root 3. So rationalizing I will get 9 root 3 by 9. We got the answer. So tan a by 2 tan b by 2 tan c by 2 is less than equal to square root 3 by 9. I hope you have enjoyed it. Find all x in the interval of 0 to pi by 2 such that square root 3 minus 1 open sin x plus square root of 3 plus 1 over cos x equals to 4 square root 2. So whenever we see root 3 plus 1 and root 3 minus 1, so we should recall the cos pi by 12 and sin pi by 12. Let us write sin pi over 12. If I want to evaluate it, I can write this is sin pi by 3 minus sin f pi by 4. That will, if we apply the formula, this will be sin pi by 3 cos pi by 4 minus cos pi by 3 sin pi by 4. Or this is equal to sin pi by 3 is 1 root 3 by 2 into 1 by root 2 minus 1 over 2 into 1 over root 2. Or I am getting sin pi by 12 equals to root 3 minus 1 over 2 root 2. In the same way, now getting to cos pi by 12, cos pi by 12 will be cos pi by 3 minus pi by 4 equal to cos pi by 4, cos pi by 3 cos pi by 4 plus sin pi by 3 sin pi by 4. That will be 1 by 2 into 1 over root 2 plus root 3 by 2 multiplies 1 over root 2. So cos pi by 12 equals to square root 3 plus 1 over 2 root 2. Now coming to question. Question is root 3 minus x square root 3 solve square root 3 minus 1 over sin x plus root 3 minus 1 over plus 1 over cos x equals to 4 root 2. I will simplify this left hand side, then I'll get here sin x into cos x. In the numerator, I'll get root 3 minus 1 cos x plus root 3 plus 1 into sin x equal to 4 root 2. So now see root 3 minus 1, I needed 2 root 2 here to make it sin pi by 12, and here also I needed 2 by 2 root 2 in the denominator of root 3 plus 1, so that I can write this as your cos pi by 12. So what I'll do, I'll multiply both the side by 1 by 2 root 2, or this will be root 3 minus 1 by 2 root 2 into cos x plus root 3 plus 1 by 2 root 2 into sin x is equals to your 4 root 2 or 2 root 2, and this sin x cos x I multiplied on the right hand side. So now I can write this will be cos root 3 minus 1 equal to your sine. So this will be sine pi by 2, pi by 12, sorry, cos x plus this one will be sine cos pi by 12 sin x equals to, and what happened to right side? Root 2 cancel, so I am getting 2 sin x cos x. Now if we take pi by 12 as a, then you are getting a plus x in your sine. So sine x plus pi by 12 equals to, what is 2 sin x cos x? It will be sin 2x. And x given, x belongs to 0 to pi by 2, it is already given. On this condition we have to solve it. So here I am getting two values in between. One is your 2x is equal to x plus 12, x plus pi by 12, sorry. So this gives us x is equal to pi by 12. The second solution will be sine x plus pi over 12 equals to sine pi minus twice x. Sine pi minus twice x is also sin x. So now I'll get x plus pi by 12 equals to pi minus 2x, or taking x together, 3x equals to pi minus pi by 12, that will be 11 pi by 12, or x equals to your 11 pi by 36. So there are two solutions of this. One is x is equal to pi by 12 and x is equal to 11 pi by 36. So solution. Thank you. One question we'll do by Johnson's inequality, other second question by different method. So let's see the first question. It is sine A plus sine B plus sine C is less than or equal to 3 square root 3 by 2. We'll prove this by Johnson's inequality. Question is, in a triangle ABC, prove that sine A plus sine of B plus sine of C is less than or equal to 3 square root 3 over 2. So if we take this sine x function, this A, B, C all are your equal to or less than 90 degree. So I am considering the function fx equals to sine x is concave in 0 to pi by 2. Let's see the graph. This is 0. This is your pi by 2. And the graph goes like this. From 0 to pi, it is your concave function, concave downward. So I can apply this Jensen inequality. What's it? For a convex function, for a concave function, I'm taking only concave, not writing convex function. For a concave function, f of x1 plus f of x2 up to f of xn whole by n is your lesser than equal to f of x1 plus x2 up to xn over n. That means your arithmetic mean is less than equal to your geometric mean. So putting this fx1 means your, I'm taking 3 here. So sine of A plus sine of B sine of C whole divided by 3. There are 3 functions here. That means fixed elements is less than equal to sine of A plus B plus C whole by 3. So sine A plus B plus C, it gives your sine 180 degree. So sine 180 by 3, this is same as your sine 60 degree, and sine 60 degree is equal to your root 3 by 2. So we are getting sine A plus sine B plus sine C is less than equal to, by 3 is less than equal to this, so root 3 by 2, or multiplying 3 to that side, right side, sine of A plus sine of B plus sine of C is less than equal to 3 root 3 over 2. So we proved. This is very simple. Thank you for watching. Another question. In a triangle ABC, prove that sine of twice A plus sine of twice B plus sine of twice C is less than equal to, again the same, 3 square root 3 over 2. So here you might observe the graph of sine 2y x. So from 0 to pi, it is not purely concave. From 0 to pi by 2, it is concave, and from pi by 2 to pi, it is convex. So inequality we cannot use from whole 0 to pi. So we'll go for different method. So LHS equals to sine of 2a plus sine of 2b plus sine of 2c. I am applying formula for this to sine a plus sine b or sine x plus sine y. That will be 2 sine x plus y by 2. So 2a plus 2b by 2 into cos 2a minus 2b by 2. And next sine 2c will be as it is. So in the next step, it will be sine a plus b multiplies cos a minus b plus sine 2c I can write as 2 sine 2i sine c and cos c. Now when a plus b plus c equals to 180 degree, because ABC is a triangle, so a plus b equals to 180 minus c. Sine of a plus b equal to sine 180 minus c. This is the same as sine c. So this can be written as 2 sine c cos a minus b plus 2 sine c cos c. So taking 2 sine c outside, it will be cos a minus b, and this cos c I can write as cos a plus b. Same logic, because cos a plus b will be cos 180 minus c, that will be minus cos c. So instead of cos c, I can write minus cos a plus b. Again, I'll put formula for this. This is nothing but your sine a and sine b. So I got 4 sine a sine b sine c. So now let us recall a previous result. I had a video uploaded about this one inequalities. If you have not watched, please watch it. Sine A sine B sine C is less than equal to 3 under root 3 over 8. So when I am getting 4 sine A sine B sine C, so I'll multiply 4 right side also. It will be 4 multiplies 3 square root 3 by 8, or this will be 3 root 3 over 2. So hence it is proved. Question is, prove that one of the roots of the equations x to the power 4 minus 10x square plus 5 is 0 is equal to 1036. That means one of these roots of this equation is 1036. You have to prove that, and you have to also find the other root. So since you know it is a quartic equation of degree 4, there are 4 roots here. X has 4 values. So we know how to reduce this equation into quadratic and to solve it. So let's begin. I'll take let x square be something t, some variable, so that the equation reduces to t square minus 10 times t plus 5 is 0. So it is a quadratic equation in t. We know quadratic formula. T equals to minus b, 10 here, plus minus b square, 10 square, 100, minus 4 into 1 into 5, whole divided by 2. So this is equal to 10 plus minus 80 square root by 2. 80 square root is 4 root 5, and cancelling with 2, I'll get 5 plus minus 2 root 5. So t equals to 5 plus minus 2 root 5. So it has two values. One is 5 plus 2 root 5 and 5 minus 2 root 5. Now when t equals to 5 plus 2 root 5, that means x square equals to 5 plus 2 root 5. So what about x? X is equal to square root of 5 plus 2 root 5. That means again there is two possibility. One is plus square root 5 plus 2 root 5 and minus square root 5 root 2 5. Now coming to when t is 5 minus 2 root 5, second case. In the same way, I'll write x square equals to 5 minus 2 root 5. This implies that x is equal to square root of 5 minus 2 root 5. Again, two possibility, one is positive, one is negative. 5 minus 2 root 5. So, the roots of this equation of the quadratic equation x to the 4 minus 10x square plus 5 equals to 0 are your plus 5 plus 2 root 5 minus 5 minus plus 2 root 5, then plus 5 minus 2 root 5, then your minus 5 minus 2 root 5. Four values are there. Now you have to identify whether out of these tan 36 is there or not. So let's find tan 36. For tan 36 we need either sin 36 or cos 36. The cos 36 degree is equal to square root 5 plus 4. It is a straight value. That means simpler than your sin 36 expression. So I'll take this value, and you can also find out this cos 36 taking your cos 18 degree or sin 18 degree, converting into this. We have already a video to prove this one. You can watch that, or if you not, you can try it. So cos 36 is equal to square root 5 plus 1 by 4. Now coming to tan 36 degree. Tan 36 degree, we know that it is sin 36 by cos 36. Sin 36 is square root of 1 minus cos square 36. And I am not taking the negative value because cos 36 is acute angle, it is in first quadrant. Now putting the value. So this is square root of 1 minus square root 5 plus 1 4 whole square whole upon your root 5 plus 1 by 4. We'll simplify this, or tan 36 equal to should be 1 minus 5 plus 1 plus 2 root 5 over 16 divided by root 5 plus 1 by 4. Now simplifying the numerator, I'll get 16 minus 5 plus 1, 6 minus 2 root 5, and this square root 16 I am taking the square root, it will be 4. Whole upon your root 5 plus 1 by 4. This 4 cancel. Ultimately I am getting in the numerator 10 minus 2 root 5 by root 5 plus 1. So getting tan 36 degree is equal to square root of 10 minus 2 root 5 by root 5 plus 1. But this does not match with the answers here. These are the 4 answers, but it does not match with any of this. So we have to bring it, the tan 36, into this form. So what will be my next step? I'll rationalize the denominator. Not rationalizing. First what I'm doing, I'm taking the 10 minus 2 root 5 and I'm taking square root plus 5 under this root. So it will be root 5 plus 1 whole square. So it will be square root 10 minus 2 root 5. Here it 5 plus 1 plus 2 root 5. Or this will be square root 10 minus 2 root 5. It will be 6 plus 2 root 5. So next step, I'll rationalize the denominator. So for this, I'll go for 10 minus 2 root 5 whole into 6 minus 2 root 5, and here in the denominator 6 plus 2 root 5 into 6 minus 2 root 5. Let us multiply the numerator. It will be 60 minus 10 root 5, 10 2 times 20 root 5 minus 12 root 5 plus 2 to the 4 plus 20 whole upon, it will be 6, a plus b, a minus b, 36 minus 20. So in the next step, it will be 60 plus 20, 80 minus 32 root 5 by 16. So 16 I'll cancel with the numerator. So what I'll get? I'm getting tan 36 degree. The final step equal to, I'll cancel with 16. It will be your 5 minus 2 square root 5. Now you can compare that we have got the result. So tan 36 degree is solution of, or one of the roots of, to the power 4 minus 10x square plus 5 equal to 0. And what is the other root? If question is in term of tan, you can write this is your tan minus tan 36 degree, because another root was minus 5 minus 2 root 5, or it can be your tan of minus 36 degree. As your tan minus 36 degree is minus tan 36 degree, but it will be minus 5 minus 2 root 5. Is prove that half plus cos pi by 20 multiplies half plus cos 3 pi by 20 multiplies half plus cos 9 pi by 20 multiplies half plus cos 27 pi over 20 equals to 1 over 16. So let's derive some formula for this expression, each factor. So we know that cos 2 theta is equals to 2 2 cos square theta minus 1 cos square theta minus 1 and 1 minus 2 sin square theta. That formula I will apply here. So applying this, I am writing the expression for 1 plus 2 cos 2 theta. 1 plus 2 is cos 2 theta equals to 1 plus 2 multiplies 1 minus 2 sin square theta. Now expanding this or multiplying, simplifying, I'll get 1 plus 2 minus 4 sin square theta, or 1 plus 2 cos theta, I may write 1 plus 2 cos 2 theta equals to 3 minus 4 sin square theta. So if I multiply 1 sin theta both in the numerator as well as the denominator, what I am getting? I am getting, in the numerator I am getting your sine cube theta, isn't it? Because this is 3 sin theta minus 4 sin cube theta for sin theta. So numerator is sine 3 theta, and of course denominator is sin theta. Now from this I'll get the expression, this one, half plus cos theta. How? I am multiplying half both the sides. So half plus 1 plus 2 cos 2 theta equals to half sine 3 theta upon sine 2 theta, sine theta. So this will give us half plus cos 2 theta equals to half sine 3 theta sine theta. So this is the derived formula we will apply for this question. Then this question will be easy or solvable. The question was product of half plus cos pi by 20 multiplies half plus cos 3 pi by 20 half plus cos 9 pi by 20 and half plus cos 27 by 20. It is 27. You have to prove that this is equal to 1 by 16. So this is equal to, if I compare with this above formula I have derived, pi by 20 is 2 theta. That means 2 theta is equals to pi by 20. So theta will be pi by 40. So it will be half multiplies your sine 3 theta. That means 3 pi by 40. And the denominator will be sine pi by 40. Multiplies half Now second one in the same way it will be 3 pi by 40. So sine 3 pi by 40 and the numerator will be sine 9 pi by 40. Multiplies half into 9 pi by 40 will be the theta and it will be sine 3 theta will be 27 pi by 40. Now coming to last expression, half into here sine 27 pi by 40. Here it will be sine 81 pi by 40. Then what? Then we got the result because these two are cancelled. These two cancel each other. 27 pi by 40 cancel each other. What remain? Remain is half sine 81 pi by 40 over sine pi by 40. Also, when you are multiplying half, you are getting 4 times. So this will be 1 by 16 into, now I'll change sine 81 pi by 40 can be written as 2 pi plus pi by 40. 2 pi plus theta is same as sine theta. So this is equal to 1 by 16 into sine pi by 40 over sine pi by 40. They will be cancelled. So the answer is 1 by 16. So cos half plus cos pi by 20 half plus cos 3 pi by 20 half plus cos 9 pi by 20 half plus cos 27 pi by 20 equals to 1 by 16 proved. I hope you